Hi, I'm Kim Simpringham at the Sports Performance Research Institute New Zealand at AUT University. The key determinants of sprint running performance include the duration of each ground contact and the magnitude and direction of the force exerted into the ground. So to improve sprint performance, it's important to understand how these variables are acutely modified by different training techniques. Recently, we completed some research with an exciting new product called the Exogen exoskeleton suit, which enables numerous loading configurations for resisted sprint training and other sports movements. Some of the configurations made possible with Exogen suits include upper versus lower, anterior versus posterior, proximal versus distal, and medial versus lateral loading. The aim of our study was to determine the changes in kinematic and kinetic variables during short sprints on a non-motorized treadmill with added lower and upper body loading using the Exogen exoskeleton, and also to determine if there was an acute potentiating effect on performance when the weights were removed. The study involved 8 athletic males completing 4 sets of 2 maximal effort sprints on a Woodway non-motorized treadmill. Participants wore the Exogen suits throughout the entire testing session. For sets 1 and 4, there was no additional load attached to the suit, and for sets 2 and 3, a load equivalent to 5% of each subject's body mass was attached either to the upper or the lower body. The use of upper and lower body loading had differential effects on the kinematics and kinetics of sprinting. External lower body loading can be used to acutely increase vertical ground reaction force by up to 5% during both the acceleration and maximum velocity sprint phases, while altering sprint kinematics such as peak velocity, contact time, and step frequency by less than 5%. External upper body loading does not affect sprinting speed, but reduces flight time by up to 15% and consequently results in decreased relative vertical ground reaction force by up to 6%. Additionally, when the weights were removed, almost all participants in the current study perceived enhanced performance in the final unloaded set of sprints. However, no significant acute enhancement of sprint performance was measured. Practitioners should be aware of the differential kinematic and kinetic effects when interpreting results and applying findings. For example, it has been theorized that longitudinal training with vest loading may result in increased eccentric strength and muscle stiffness. It would seem from the results of this study, however, that lower body loading provides a more effective vertical training stimulus at a load of 5% of body mass, and therefore possibly a better loading strategy to increase eccentric strength and stiffness. For more information about our research at Sprins, you can visit our website, and for more information about the Exogen product, visit Leela's website at movementrevolution.com.